Hello! In this video tutorial, we will cover all features of Land's design for creating and modeling terrains. We will start by showing how to scan and import points from the web, as well as creating them from DEM files. Then we will start a new project, creating a new terrain from curves. We'll check its properties and options, such as the level of detail of the mesh, contour line display options, managing input data, or changing a terrain's material. We will run some operations to modify the terrain, such as picking a new boundary, adding a new contour as input data, a hole, a cut and fill, a path, and a subdivision. We will end by learning how to insert a list with terrain information such as areas and volumes. Let's start by scanning and importing a terrain from the web. We can do this from the terrain toolbar using this icon, or from the Land's Design menu, Terrain Modeling, and running the Import Earth Elevation Data command. This opens the Import Earth Elevation Data dialog, where we can navigate over the world until we find the desired area we want to scan. We can use the search bar to find a specific location. Let's find somewhere around the Pyrenees, let's say Andorra. So then we need to zoom in. Please note that the extension is limited to 10 kilometers alongside both axes. So we need to zoom in some more until we find the desired spot. Notice that we have this widget that indicates the center of the area that we're going to scan, and that corresponds to 0 coordinates in the document. There are two options to import the area. One is by importing a textured mesh according to this picture. The other one is creating a Land's terrain on the same scanned area. From this elevation data, we can define the accuracy of the imported terrain. Here we'll see the number of samples per meter that will generate the geometry. Currently, the data source provides samples every 30 meters, so any lower value will correspond to interpolated points. If we choose to create the mesh option, we'll import the image that we see here. We can also choose the streets option, outdoors, or satellite streets. I'll go back to the first option. We can define the boundary of the area that we want to import by using this rectangle icon, and then selecting with a cross window. Actually, if we collapse the dialog, we can make this area bigger. Then just click on the import option. And there we go. Let's maximize the perspective viewport so we can see the textured mesh. We need to, of course, set the display to rendered mode. If we select this object in the Land's Design Edit panel, we can see it has been tagged already as a terrain. This means that all the plants, elements that we put on it will be projected on top of the mesh surface. Now, if we run the command again, we will be able to import the neighboring areas of this mesh terrain. Let's go ahead and try that. We can click on these arrows to automatically select the neighboring regions and be able to import them. Important to note, under the geolocalized document settings, we do not want to click on this checkbox. Otherwise, it'll relocate the original coordinates according to the center position of the new region. Now simply click on Import. Let's do the same with the two neighboring areas. By right-clicking in the command line, we can access the previously run commands. And then just go ahead and repeat the process. And one last time. There we go. I have 4 different meshes. I'll select them all and group them. Now I can select them in a single click. Let's repeat the process, this time to generate a terrain in a specific area. For example, around here. Let's run the command one more time. I will go back to the original imported area, click on the rectangle to window select a small portion of the terrain. This time choosing the Create Lands Terrain option instead. When I import the selection, I'll see a terrain generated exactly on that position. Another way to import terrains in Lands Design is by importing GIS data. Access through the Lands Design menu, Terrain Modeling, click the first option. It lets us select SHP files that may contain geometry that will be used to generate the terrain later on. Or there's the option to import a digital elevation model to create a new terrain. Let's check this option for now. This dialog appears, allowing us to select DEM files. Basically, DEM files are simple and regularly spaced grid of elevation values. Available as TIFF, PNG, text, ASC formats. I'm going to select this example file. And now we need to zoom in the area we want to scan. The detail resolution of this file is quite high. I'm going to select a small portion. You get the option to import curves into specific layers. You can also generate a mesh in addition to a terrain. Or just import the terrain. Takes a few minutes to calculate. And there it is. If we select it, we can see the terrain listed in the Lands Design Edit panel. We can show the contour lines and work on them. We're now ready to start modeling this project. Here's the finalized version. We will use it as an example to go through the main terrain modeling tools using this terrain park. Let's start from the beginning by opening a new file. Select the Lands Design template. We could start working on the 2D guidelines of the project. Or, as in this case, I'll insert an AutoCAD file that contains all the guidelines that we need. Go to File, Import, and select the AutoCAD file. I'll validate the default import options. Here it is. If we check the Layers panel, we'll see that some of the line work is already placed on specific layers. I'll rename the last one to 2D. Drag the 3 layers as children to the 2D layer I just created. This way I can control the whole visibility of the line work by deactivating the parent layer. Terrains in Lands Design are created from 3D curves and 3D points in the 3D model space. So the first thing we need to do is elevate these curves to generate a terrain from them. I'm going to hide all these layers, except those that contain the topography lines. which are now all placed on the same elevation or Z height. I'll run the elevate curves command. I need to define a line that intersects the lines I want to elevate. Then define the increment step and click on Apply. We can see the changes. I'll run it again, draw a new line to elevate the rest of the curves. Click on Apply. Now we can close the dialog to accept the changes. We can observe the curves elevated in 3D space. We're ready to run the terrain command. Terrains are created using a Delaunay triangulation method. But if we choose the gridded surface shapes to triangulation option, we will be able to define the cell size and have more control on the level of detail of the resulting terrain. We'll go over the rest of the settings later on. Let's click OK. Select all these curves, press Enter. We can see the terrain has been generated. Now let's hide the topography curves. Select the terrain, and under the Edit panel, let's check its properties. Here we can define the cell size, we can uncheck the smooth option if we don't want it to be created so smoothly. If we uncheck the simplify option, we will generate the terrain with an even cell size all over the mesh. I recommend unchecking it for a lighter object. You can change the base height of the terrain in this value box. If we explore the other tabs, such as Control Lines, here we can configure how these curves will display on the 2D terrain. We can choose by total number of contours or by distance between each. For example, let's set it by distance to a distance of 0.2 meters. So now, when we show the terrain in 2D, we will see the contour lines, evenly spaced every 20 centimeters. Another option in the Contour Lines tab is to enable the index contours every certain number setting. It allows us to set specific attributes such as line type and color for specific contours, as we can see here. Let's switch it back to the 3D display. Note, we can actually show the terrain in both 2D and 3D at the same time by clicking here. If we continue exploring the terrain, we'll see that the 7 curves that we used to generate it are stored in the Input Data tab. We can select them individually under the Elevation Data list, remove it if necessary, or uncheck the control point visibility to unclutter the view. If we move the contour control points around, we will change the topography of the terrain, which will adapt accordingly. Let's undo the changes. Under the Materials tab, we can change the default material assigned to the terrain. I'm going to browse for a new one inside the Lands Material library. I'll select this brush, for example. Now, under the General tab, you'll find common attributes such as the name, color, or layer it belongs to. As soon as we generate this terrain, a new layer is created as well, placing that object according to the layer structure in the document. Now I'm going to turn on the layer where I have the 2D curves. The first operation I will do is to define a new boundary for the existing terrain. I'll start by creating a polyline larger than the drawing I want to keep. Then run the terrain boundary command that can be found in this toolbar. There are different ways to achieve this. We could just create a polyline that follows the overall boundary. Instead, I'm going to use some of the existing curves that I already have. I'm going to switch to the 2D view and work from the top viewport. I'll draw a polyline that will be used as the new boundary. Now, I select the polyline and all the curves around the new boundary. I'm going to isolate the selection using the Isolate button in Rhino's Visibility toolbar. I'll run the curve boolean command, found here. I'll select all the curves, click inside one of these regions, say here to the left, select curves as the output in the command line, and hit enter. As a result, I get a polyline that I will use as a terrain boundary. We'll run the same process on the other side, this time creating a surface instead of a curve. I'll run the curve boolean command again, select all curves, click surfaces as output, and click inside the desired region. In the perspective view, we can distinguish the surface. I'll select it, right-click on the terrain layer, and move the object to this layer. Now I can hide the guidelines layer, show all hidden objects back again, and change the terrain visibility back to 3D. Now I'll run the terrain boundary command. Select the terrain, select a closed curve, and we obtain the new terrain generated using the new boundary. If we select the terrain and go to the Input Data tab, we can see this boundary in the list. We could remove it to restore the original shape of the terrain. By moving around the control points of the boundary, we can change the terrain's limit shape. Let's undo the changes. If we insert new objects in this project, and if they are within the boundaries of the terrain, they'll be automatically placed on top of it as long as we have this icon enabled. If we want the same behavior on this surface, we need to tag it as a terrain. We can do this by selecting the surface and clicking on the Tag as Terrain option in the Edit panel. The next command we'll see is how to add a new contour to the terrain, so we have more control over its elevation data. For example, I'm going to create a point around here. I'll run the point command, snap to this corner, and I'll move it to a new height in Z. I'll use it as new input data for the terrain. I'll run the Add Contour command, select the terrain, select curves or points, hit enter so the terrain integrates this point as new elevation data. That we can find here in the Input Data tab. Let's learn how to insert a hole in the terrain. We'll pretend we need to do an excavation to place some kind of construction. First, we need to define the boundary of the hole, so I'll create a rectangle around this area. I'll switch to ghosted mode so we can see the curve. The elevation of the curve will determine the position of the hole in the terrain. It's important that it's not located above or we won't be able to appreciate the hole. I'll move it downward. Just a little deeper. Now I can run the whole command. Select the terrain, select the curve, and we've generated the indented area. Actually, if we select the terrain and look in the panel, we can see a subdivision object has been created. This will allow us to change the material or the color. Let's go to the General tab, and there we can change colors or any other attribute. If we check the Input Data tab, we can see both the hull and the subdivision object generated. We could create a zone in that area. For now, I'll just remove it. If we need to create sharp edges around the hull, we can uncheck Use the grid to model holes and cut and fill. I'll switch to Render Display mode. We can change the limits of the hull by pulling the control points of the original rectangle. Or we can change its elevation by moving the whole rectangle in Z. We'll do a similar operation using the Cut and Fill command. I'll start by removing this existing hull. I'll select the terrain and check the setting on again. We'll now use the same rectangle curve for the cut and fill operation. Let's switch to ghosted mode. I'll place the curve in a position where it is partially inside the terrain and partially outside its volume. Sort of like this. The cut and fill will remove the part of the terrain that intersects the curve and add volume on the part of the curve that is above the terrain. We could actually have the curve in a different plane than the XY. So let's rotate it a little bit. I'll also slightly move it so that it intersects the terrain some more. Now I'll run the Cut and Fill command, pick the terrain, pick an angle for the slope around the curve. This basically defines how the terrain will intersect with the curve. 45 degrees is fine, and finally I'll select the closed curve. You can see how the terrain has been modified to comply with the position of the curve. If we add a higher level of detail to the terrain, we'll get a smoother result around the curve area. Just as with the hull, this operation has generated a new subdivision object, to which we can change various attributes such as material. So let's go to the material library and check any of these folders. Pick any material. We'll switch to rendered mode to make the changes visible. Now let's go to the Input Data tab, select the subdivision object, generate a zone, or remove it. Now we're back to the original terrain shape. The next step is to learn how to add a path to the terrain. I'm going to turn on the layer for the guidelines. Set it to ghosted display so that we can see the path curves. I need to define the center line of these two curves to use as a path axis. So first of all, I'm going to select the curves. It seems they're broken into multiple parts, so I'll hold down the Shift key to add to my selection. Then I'll join them together into one open curve. Now I can run the offset curve command, set the distance, let's say 1.5 meters, and click towards the inside for the offset direction. This will be the curve I'll use for adding a path to the terrain. I'm going to trim the excess part of the curve. So I'll run the trim command, select the line as the cutting object, hit enter, and then click on the end to make it disappear. Notice that we've got this curve on the 0 elevation. That means that the path will be placed in that position. Let's check it out. Go to the terrain toolbar, click on the Add Path command, select the terrain. Now we can define the width, which is, let's say, 3 meters. Hit enter. Pick an angle for the slope along the path. Let's say 45 degrees. And finally, pick the curve. And there we go. When generating a path, a subdivision object is created along the path area. We can select the terrain, go to the Edit panel. Under the Input Data tab, we can see the subdivision object listed. We can also create a zone for this path, or select it from the terrain list, and assign different attributes, such as material or color. For example, let's change the texture, browsing to the material library, and selecting any of the images available. Note that the terrain has inherited the control points of the curve that we have used to generate the path. That means that I can select any of these control points, pull them up to modify the position and shape of the path. Let's change to rendered mode. It looks a bit strange. I don't want the path to be so indented in the terrain. Let's repeat the operation. This time, I'll select the path axis and project onto the terrain before creating the path. I'll delete that path under the Input Data tab. Select and remove it. This will also remove the subdivision object. Now back to ghosted mode, so that I can select the path axis. Go to the Edit panel under Adjust, select To Terrain. This will project the curve onto the existing terrain topography. I'll run the path command again. Pick the terrain, select the same width, same angle, and finally select the projected curve. And there we go. Now I'll select the path subdivision so that I can assign a new texture, browsing through the Lands Material Library. Now this will be visible when we change to Render Display Mode. We need to pull the end control point of the curve defining the path axis so that the path subdivision object extends at least to the border of the terrain. In this last part, we will learn how to add a subdivision object in an area of the terrain. We've added them previously when creating paths, cut-in fills, or holes on the terrain. In this case, we will use the command to create an individual subdivision object that defines a part of the terrain. I'll hide the terrain momentarily so that we can run the curve boolean commands selecting these curves and clicking in this inner part to generate a boundary. I'll choose to output curves, and this is a closed curve that I will use to create the subdivision object. I'll right-click on the bulb icon to show the terrain back again. Run the divide command, pick the terrain, select a closed curve, and there we go. If we select the terrain and go to the Edit panel, we'll see a subdivision for the path and one for the inner region we just created. So now we can assign different materials, colors, and other settings from these two tabs. In this case, I'll assign a different color, but keep the same texture. Since we've run a few operations on the terrain, we're now going to see how to list information such as volume that has been added or removed to the terrain. Let's click on this icon, select the terrain, and the dialog pops up with this information. We can show it as a list. I'll go to the Lands documentation. Under the listing commands, click on the Terrain List button. It creates a block of text showing the area for each subdivision, the path, and the smaller region, as well as a volume of the fill and the dig that were generated after the path operation, comparing the final result against the original terrain. To finish this tutorial, I'll change the material for the whole terrain. So let's go to the Material tab, click on Browse, Textures folder, and select this image. I'll change the width as well, and change the material for the smaller subdivision area. So again, selecting it, and then browsing through the library, selecting a different image. Let's scale it by 10, and there we go. Thank you for watching.